This is Problem Solved, the IISE podcast, where we talk to industrial and systems engineers about their work, ideas, and solutions.
Hello, and welcome to Problem Solved, the IISE podcast, the final part of our triple episode premiere. In this episode, IISE's James Swisher interviews Michael J. Pyrcz, Associate Professor at the University of Texas at Austin, and our third keynote speaker for the Lean Six Sigma and Data Science Conference, taking place live September 20th through the 22nd at the Grand Hyatt Buckhead in Atlanta. You can learn more about the conference program, registration, and health and safety measures by visiting the conference website at iise.org/Lean Six Sigma. But now, please enjoy this episode with our guest, Michael Pyrcz.
Michael, thank you so much for joining us today.
It's my pleasure to be here, James. Thank you.
Well, we really appreciate it. We're excited to have you. Excited to have you on the podcast today, and excited to have you as a keynote speaker at our Lean Six Sigma and Data Science Conference in September. For many, many reasons, we're excited to have you. But one of the things that I'm excited to hear about today is a story that you share on your website about how in high school you struck up a conversation at a gas station of all places with a student engineer, and that got you hooked on pursuing an engineering education. So I'd love to hear more about that. Could you tell our audience about it?
Hey, thanks a lot, James. I'll tell you what, I still pinch myself. I can't believe I'm an engineer. I can't believe it actually worked out. See, the thing you have to understand about me is that growing up, I came from a low-income family. There was issues like alcoholism and so forth in the home. And I was working from quite a young age, just to, clothing and basic necessities. I was working full-time in high school. And so You can imagine working full-time in high school. I wasn't exactly top of the class. I was slipping through a lot of classes.
Right.
And one night I was coming home late, a dark, cold evening in Canada, coming home from that pizza restaurant. And I stopped to fuel up my junker, the vehicle I could barely afford. Right. And, being a Canadian, we just kind of have conversations with strangers all the time. So I'm standing there.
Polite conversations with strangers.
So I'm filling up that Mustang II, 1978. And there was a person on the other side of the pump just starts talking to me. And it was kind of a nice conversation, casual. And then they suddenly turned to me and they said, pointing at my car, they said, "Do you know how that works?"
Interesting.
And I was kind of taken aback. I was like, well, I kind of stumbled a bit. I said, 4-stroke. I think I know something about internal combustion engines. And they said, no, how it really works. And I said, I guess not. And they came over on my side of the pump and it was frosty and cold. They drew the Carnot theoretical cycle on my windshield.
Oh, wow.
And they started to explain that they were a student engineer at the University of Alberta working on the temperature, like using advanced ceramics and engine blocks so they could operate at higher temperatures, and talking about how they could get better efficiency. And I was sitting there going like, that's really cool. And they started to talk about, mechanical engineering and all these different projects. And I realized I could understand what they were talking about. I don't think I'd ever really met an engineer before that, or engineering student. So the next day I went back to the high school and I met with my guidance counselor. Yeah, I sat down with them, and believe me, they'd never seen me before.
They said, "Who is this guy?"
You know what I mean? And I just walked in. I said, "Hey, I'm thinking that university thing, engineering, that sounds great." And it took him about a minute to look me up, look at the scores, and turn to me and say, "Michael, university is not for everybody." And I got to tell you, that made me so mad.
I bet.
I was mad, and I was scared. I was scared. Sure. I realized I was on a path that was leading me where I didn't want to go. And so I went straight to that restaurant. I let them know I wasn't going to work full time anymore. I cut those hours. I let the junker turn into more of a junker than ever before. And I focused. And the very next year I had honors, I had great marks. And fortunately in Canada, they only look at grade 12 when you go for university admissions. So I got in.
Oh, wow.
Well, I was on fire. I was at home. I loved every part of it. And I was just into it. I graduated number 1 in my engineering class.
Oh, wow. And congratulations.
And that's what led to, well, thank you very much. I have the gold medal on my shelf.
I love it.
Yeah. And so that's it. A PhD in engineering. Everything just flowed from there. It was just perfect. And I've traveled the world. I've had all kinds of opportunities because of it.
Wow. What an awesome story. That is really cool. It's these chance meetings that we have in our lives sometimes that just set us on a course. It's remarkable.
And I got to tell you, James, as a professor, that was part of my motivation. I had 13 years of experience in industry. And when I had the chance to become a professor, I thought, boy, now I can be a voice. I can be with potential. I can inspire people to go into science and engineering and just what an impact we can have, And I recognize that I got all the time I meet with students and I think, is this like what I was like before when I hadn't caught fire yet, when I didn't understand yet, right?
Yeah. That's awesome. And in a few years, some of those folks are going to be on a podcast talking about how Dr. Pyrcz influenced their life.
Hey, James, be careful. You're going to get me all teary here. I do. I have a lot of passion, and I do know. We talk at the University of Texas, Austin about changing the world.
Yeah.
And I do know we can change people's worlds.
That's not an unattainable goal. Sometimes it feels that way, but we can change the world just a little bit at a time and just one person at a time.
And for that one person, that's a lot.
Yeah, it is.
Yeah,
it is. Oh, what a great story. Well, I guess since then you've gone on to a pretty esteemed career and are very well known in geostatistics, spatial data, and data analysis. I'm wondering, what's happening in geostatistics and spatial data. How are those being applied in today's world? Do you see industries that should be using that kind of technology and data and that aren't?
So I'll tell you what, there is so much excitement around data analytics, machine learning, the fourth paradigm of scientific discovery, data-driven technologies. It's amazing. We're literally swimming in data right now.
Yeah.
Everybody's thinking about how can we acquire this data? How can we use this data? And there's a rush. There's a bit of a rush to try to use machine learning technologies.
Yeah.
And I'm seeing a lot of that going on right now. But 90%. Have you ever heard this? That 90% of data-driven modeling is data preparation and cleanup?
No, really.
It's 90%. Actually, when I visit
that's a little frustrating, isn't it?
Often by the time you get to modeling, it's kind of plug and chug. It's kind of getting ready, right? And I'll tell you what, many of our engineering challenges are spatial. That's what's really exciting to me is, in fact, people try to solve these problems without accounting for the spatial context. But fundamentally, they are spatial problems. And so why is geostatistics meaningful? It's a branch of statistics that integrates scale, local conditioning data and trends, heterogeneity, uncertainty. And so when you think about it, you can't do spatial without geostatistics. You need it. And so what I'm seeing right now is just tons of opportunities to use the geostatistics.
That's awesome.
What's really interesting to me, James, is if you look at machine learning methodologies, the way they're being used off the shelf, they're ignoring the spatial context.
Interesting.
They really are. They're treating all of our problems like they're a multivariate table.
Right.
We can imagine rows with samples and columns with all the variables, or they call them features.
Sure.
And they're just throwing them into the machine. They're ignoring the spatial context. So with geostatistics and methods based on spatial data analytics, we can improve these methods so that we can account for space and do a much better job. In fact, a Geostat Congress happened last week. Did you hear about that?
No. Tell me about it.
Congress. It's the Olympics in spatial data analytics.
Oh,
it happens only once every 4 years.
Awesome.
And it's the gathering of all the greats in the field, all the people that I respect in the area of geostats are there. And I had 4 or 5 students presenting. I did a workshop there.
Does that make you the Simone Biles of the Geostatistics Congress?
I was told that I had a great contribution to the conference with
there
a lot
you
of
go.
tips and so forth. So I don't know.
I say that's a gold medal.
I don't know if I would put myself at the level of Jeff Kers and Clayton Deutsch, my PhD advisor, and Mohan Srivastava, the organizer, but it's a great group and we definitely did participate a lot. But what's interesting to me is that when I look at the Congress and I look at the talks, mining and petroleum, the subsurface resource industries are dominating this research. They're really dominating this field. And so when I look at it, what I say is, where's everybody else?
Right.
Where are the geotechnical engineers? Where are the people who are working with environmental? Where are the people who are working with all the renewable energy sources that are so essential to to our society right now. And if you ask me, James, I think that's evidence that those industries, those sectors, that's a gap. That's an opportunity for them to be incorporating this type of science into what they do. Now, let me just, if I can say one more thing about it.
Yeah.
If we ignore the spatial context, we do it at our own peril.
Sure.
Because we will either, depending on the case, we will either, and this usually happens, grossly underestimate uncertainty. But there's other cases where we'll, in fact, overestimate uncertainty. But I'll tell you what we'll always do. We're going to always introduce bias.
Right.
No matter what we do. So, and what happens then? Well, I tell my students, if you don't impact the decision, you don't have you don't add value.
Yeah.
And so what I'd say is that if we're producing bad models with bad uncertainty and biased results, we're going to be making suboptimal decisions in engineering. Yeah. So that's a bit of a soapbox for me, James. I think we're really missing out on an opportunity.
Yeah, I think you're right. And I know you've hit on a key point there. Certainly bias in modeling, particularly machine learning, artificial intelligence is certainly a hot topic right now. And how do you help your students not have their thumb on the scale, so to speak?
Well, so the first thing is this. You ever watch Mythbusters?
Yeah.
So I have 3 kids and they all grew up watching Mythbusters, which I just thought was great. Jamie and Adam. I take a Mythbusters approach with my work.
Okay.
In other words, if everything works, everything's fine, I'm a little disappointed. You know what Jamie and Adam will do is if it doesn't blow up, they'll just add more pressure.
Right.
They'll put more force.
Right.
They'll increase the speed. And so that's what we do with our modeling. I like to take things till they break, and then we understand why they broke.
That's smart.
Yeah, I think, and if I think about it, that's the scientific method to always try to disprove, be scientifically proven.
It really is.
Yeah. But we have seen a lot of that where it's like the people kind of toy with it until it works, and then they're like, take lots of pictures of it and show it.
Right.
So
we only take good pictures of our children, right? You don't take the messy pictures.
No, we gotta. You know what? And we can't treat our models like they're our children. We can't fall in love with our models. We gotta try to keep updating, keep learning for sure. Now you talk about bias. One of my PhD students, Wendy Liu, what she actually did was she answered that question. We created spatially biased data sets and we fed them through machine learning methods.
Yeah.
And what was fascinating? If they train with biased data, but then you test them, you apply them with unbiased data, guess what? That signature, that pattern of bias remains.
Right.
And the problem is with machine learning is often the models don't have a high interpretability. You won't know what's happening. So we actually did propose a method for spatial debiasing machine learning method. So we're thinking a lot about that right now.
That's really fascinating.
Yeah. And you know why, James? It turns out that all sparsely sampled spatial data sets are biased. I think I can say that.
Yeah. Yeah, that's a truism.
Yeah, but we don't. And in fact, can you imagine if you went into your engineering job and you said, I think we should just do sampling randomly and it's expensive to sample? No, you sample to add value, sample to reduce uncertainty.
Right.
Representative sampling would be very difficult to sell in many fields, especially the subsurface. It costs $150 million to put a well in the deep water Gulf of Mexico. I can't do that randomly.
No, that's not just pocket change and lint, is it? Well, you mentioned that there's sort of a lack of some fields showing up these days. How do you think we get more people involved in using spatial data?
Yeah. And James, I think it all comes down to accessible education. Last year alone, I trained 1,700 working professionals in 44 engagements.
Wow. I
have a YouTube channel with every one of my lectures from the university. And this is pre-COVID. I didn't do this because of COVID, but I didn't record in the classroom. I recorded by my desk in order to produce like a good product for people to watch.
Yeah.
And I'll tell you what, 20,000 views per month.
Wow.
And these are engineers from all over the world, and they're gaining new skills. What I also do is I build kind of well-documented workflows, interactivities, because the best way to learn data-driven methods and models is to play with them.
Right.
So when I teach engineers and I use this content, I find they learn pretty quickly. And so I think it's producing content. It's up to us. We have to assist our fellow engineers in this transition. Now, I also think there's some fear, James. I think there's this kind of the machine is going to replace us kind of thing.
Right.
And I think there is managing expectations so people can understand how the machines can kind of augment, can assist, can help us do our jobs, add value. But the way I like to say it is engineers will have more time to do engineering.
Yeah, that's right.
Engineers will have better lenses to be able to explore and see complicated systems. That's my approach to it.
I think that makes a lot of sense. And that's something that is not easy, at least today, not easily replaceable by a machine, that human judgment and discernment. So yeah, let the computer do all the crunching, and then you draw the conclusions and make the recommendations, right?
Yeah, and we're going to retire with less ergonomic injuries.
Yes, that's exactly right. Yeah, I can still remember my undergraduate senior design project trying to key in all that data. It's a wonder we don't all have carpal tunnel from that.
Exactly, and I've seen it in the field of geophysics where people are making interpretations on the old workstations, and you could hear them in their office just click, 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 click as they're interpreting on all these sections. And then the transition to guided interpretation workflows where you interact with the machine. Yeah. And imagine you click on a location in the geophysical information. You say, I think something's there, and it suggests how to propagate away from it. Then you go, no, bad machine. You got it wrong. And the machine goes, okay, I learned something from you. And then it tries again. Imagine that versus you're manually trying to click on all those sections.
Yeah, absolutely. That's where we want to go.
Yep. And then I'll tell you what, another thing is many of our engineering problems are so high dimensional, so complicated. And I get really excited about dimensionality reduction when you can see your problems in a low dimensional space. You can start to interpret and learn new things, see new things, Absolutely. And we can also find out when multiple competing information sources start to be contradictory. And then we can go back and understand, okay, what went wrong?
Right.
Yeah. Right. Yeah. We need that help from the machines.
We do. My dad was and is a farmer all his life, and he would say that's separating the wheat from the chaff, right? That's what are the critical few important ones and the trivial many. So,
something really interesting, and I'm just thinking about some of the research we've been doing recently. One of my senior PhD students actually built a very interesting machine. It took a variety of subsurface models, and then it looked at how we can update them with information about flow rates. Because, we know what rate is being injected, the water being injected at wells, and the rates of hydrocarbons being recovered. And that's a large scale piece of information about connectivity. But what he found was with the machine, he could project it into a lower dimensional space.
Yeah.
And then now we could turn just a couple of dials, and we could actually explore the uncertainty of the subsurface. And now we could use methods like ensemble Kalman filtering to try to update and match the engineering historical production information.
Yes.
And it was so cool because traditionally when people would do that directly on a huge high dimensional field, the entire permeability at all locations, like these models are 10 million cells.
Right.
And they're trying to update that. And when they did that, they would actually wreck the geologic structure, the geophysical integration. These models don't do that. They actually allow us to turn fewer dials and to be consistent with our information sources. It's amazing. It really is.
It's really awesome. And there's always, at least for me, there's always that sense of discovery. Like when you're able to reduce the model that way, you just have this wonderful sense of accomplishment. Like, aha, now I understand.
Yeah. And what we hope is that we're going to learn new things about the subsurface. We're going to learn new hypotheses, and then we're going to be able to go back to the geology, back to the geophysics and engineering data and look for those things.
Yeah.
And then new opportunities. But I agree with what you said before. I don't think the machines will be creative on their own. Not for a long time. Without getting kind of sci-fi on you here.
Right.
I think the creativity will come as you said, we'll see things differently, and then we'll learn new things and think of new ideas.
I think at least in our lifetime, we're safe. I don't think the machines are going to take over in our lifetime.
So James, am I allowed to make one Skynet joke? May I have one Skynet joke?
Of course. Yeah, absolutely. I mean, it wouldn't be an episode without a Skynet joke.
Every time I taught actually at Chevron this week for 3 days about deep learning, and I think I made probably 6 Skynet jokes over 3 days. It's so hard not to do it because and I think it's good because we do recognize the fact that, well, these machines, what we're teaching them to do is very basic. Even though it's very powerful, but they're not showing creativity. They're
right.
not, when they detect patterns in the subsurface, even these advanced deep learning methods, usually you can explore and realize that it's not that complicated.
Right.
It's pretty cool. We can figure out if it's a muffin or a dog. And right. I got to tell you, being able to do that over large volumes of data, that's the advantage, because then you can go through and spot those, as you said, wheat from the chaff, right? And do it without getting ergonomic injury or spend all your engineering time trying to do that.
Well, you mentioned your YouTube channel earlier, and I'm wondering, do you see the long-term impacts from the pandemic in terms of remote learning? Do you see things like your YouTube channel and remote learning platforms becoming a more dominant model for learning in the future? Or do you think things will go back to the way they were?
Oh, geez, this is a very good question, James. I'll tell you, it was a big shock to all of us in education.
Yeah.
Because I got to tell you, one of the best parts of the job is standing in the lecture hall.
Absolutely.
I absolutely adore it. I love when I'll introduce a new concept like statistical bootstrap. I can look out at like 80 students, and these are great students. These are very intelligent people.
Right.
And I can say, hey, who's heard of spatial bootstrap or statistical bootstrap? And nobody has. And I can turn and I can say, today is truly a great day, because I get to be the one to introduce you to like one of the most powerful statistical developments of the last century, that kind of thing. You don't get that rush when you do it on Zoom.
Right.
You really do lose that. The degree of interactivity is more challenged. Now, I have to say, I had an advantage. I teach data analytics, geostats, and machine learning. My course is translated well to the remote learning environment. I can't wait to be back in the classroom. What are we going to take from it, though? I got to tell you, there are many times where I just popped into a company for a 1-hour meeting and I didn't make the drive.
Right.
And I hope we keep doing that.
I would agree.
As a professor, I think it's really important to have one foot in industry, to spend a lot of time, have a lot of contact with the working professionals. In fact, part of the YouTube channel is to support working professionals. I think we should be serving the state of Texas and beyond as professors here. So I hope that we retain that. The other thing is we were challenged to create, myself, I felt a lot of challenge to create compelling content, interactivity, to kind of assist with remote learning. Well, I'm going to keep doing that. I'm going to keep showing that. Students are going to use that to complete their homework assignments. I think that'll still be good to have.
That's good. So it sounds like find some ways to keep the beneficial parts, but get back to live in-person training and education wherever we can.
Yep. And I'll tell you what, it's all going to remove barriers. It's going to allow people off of campus to have access to our resources. I think that's great, but don't tell the chair. This is just keep this between us. I'm going to still try to work from home 1 or 2 days a week, because as a professor, let me tell you, your time can be very fragmented when you're in the office.
Oh, I bet. Yeah.
I tend to have an open door policy with all my 15 PhD students, and other undergrads will just show up. I was often staying until 9 o'clock or later in the office to get my job done, So I may work from home 1 or 2. Yeah, I think a lot of us are going to do that, right, James? We're going to work from home still a little, right?
I think so. And I think that's smart. I mean, it helps everybody have a work-life balance, and you're still able to be effective.
When I meet with people in companies, the management's saying that. They're saying, we never knew.
Right.
We never knew people were going to be actually more productive when they're able to kind of sit there in their slippers.
It is remarkable. It really is. Well, you're cutting out so much of that non-value added time, getting in the car and commuting and all of those little things that add up to time.
And let's face it, the quality of your breaks you take at home. Like I literally take the dog for a walk around the neighborhood. You feel so refreshed. You come back in, you're good, more productive.
No doubt. Well, tell me a little bit. You mentioned the effects of the pandemic for you. How about for your students? Do you see students moving in a different direction post-pandemic in terms of what they're interested in?
Yeah, I got to tell you, it's really hard for me to deconvolve the pandemic from also the digital revolution.
Yeah.
Because both of those are kind of going on at the same time. My courses in data analytics, geostats, and machine learning are filling up literally within hours of opening.
Wow.
Like there's so much demand for this knowledge right now. In fact, what's amazing is I had several undergraduate researchers last semester, which is really unheard of. That's kind of a huge load.
Yeah.
And these are students who just really want to gain these types of skills and get more kind of credibility and knowledge and skills and demonstrations and so forth that they could share. And so there's a huge interest among engineering students to have data analytics and machine learning skills. So I'm seeing that. I'm definitely seeing a lot of that. I think that what these students are also realizing is that if they're putting on their CV that they know data analytics and machine learning, that they need products.
Right.
They need to have something to show. And that's what I tell them. I say, hey, if you're going to have that on your CV, you should have a GitHub repository, open source, where people can see or contribute to other people's open source content.
Sure.
And that's a great thing. That's actually the real CV for this field, these topics. So I'm seeing a lot of students really seeking these skill sets. At the same time, on the other side, I see pull. When I visit companies, they keep asking me, where can we find the engineering students who have these skills?
Right.
So for me in this field, very exciting right now, for sure.
Absolutely. Future is very bright. Well, we're really excited, speaking of bright futures and getting back to live in-person interactions. So we're really excited about the Lean Six Sigma and Data Science Conference in September, and very, very grateful and excited to have you as a keynote speaker. Can you give us a sneak peek of maybe what you might be sharing? You don't want to give away too much, but maybe just a little bit of what you're going to share.
Geez, I'm not very good at PR here, James. So right now, let me just apologize. I'm either going to say too much or too little. And if I'm personally responsible for destroying your conference, I apologize. I feel a huge weight of responsibility on my shoulders right now.
Oh, don't at all. Whatever you say will be perfect.
So ever since I got the invite, and I do appreciate the invite, and I love it. I hope you can see it's very special to me to be able to address a large group of engineers and to be able to make statements about education and opportunities. I've been thinking a lot about it. And I'll tell you, I've been reflecting on all of the professionals I've taught in the last year. Like literally so many. It's been so exciting and so great. And what I've seen is there's so many engineers that are really interested in learning new skills, being able to immediately add value at work, have basically build up that toolkit, your engineering toolkit, and look at data and look at problems differently and find new lenses to see the world. And so what I've been thinking a lot about what that means. Like, what does the profession of engineering mean in the fourth paradigm, the data-driven discovery era?
Right.
And so I've been thinking about specifically how can we augment the first, the second, and third paradigm? Just to recap that, James, the first paradigm was that idea of experimentation. We've been doing that for thousands of years, right? We've been exploring our environment by doing experiments. Second paradigm was this idea of theoretical science, finding the fundamental laws. The third paradigm was computer simulation. We found out the world was too heterogeneous, too complicated. We couldn't solve it all by first principles.
Right.
And so I've been thinking about what it is to be an engineer and how we can use what we're very good at, the first, second, and third paradigm. We do that. We got that. Let me put that. We got that.
Right.
And how we can plug that in, use that in the fourth paradigm. And so I'm excited. I actually think there's great opportunities. So you're going to see me show up and just be ecstatic.
Awesome.
Just very excited and share a very positive message. But I am a scientist and I am a Mythbusters approach. And so there's going to be that, that voice inside your head, that kind of negative one that kind of says, this ain't going to go well.
Right.
Well, that voice is saying, that inner critical scientist who says, okay, what could be the problems? What are the pitfalls? And so I am concerned about some things. I'm concerned about some directions and trends and a dilution or departure from fundamental engineering. I think a little bit critically about that. Dr. Torres Verdin from my department had a great quote. Don't use machine learning as a crutch instead of understanding the fundamental science and engineering.
It's a great point.
And so look for me to make some negative comments. I'm going to be kind of getting a little grumpy here. And, and I'm going
to have a devil on one shoulder and an angel on the other.
It's going to be pretty crazy. Let's put it that way. It's going to go back and forth. And so I'm going to talk about engineering practice and our responsibilities, understanding and checking our models. And that's for sure going to happen. I have gone, let me just put it this way. I go to tech meetups. I love it. I'm kind of on the tech side, the engineering side at the same time. And I've heard people make the following statement, and it keeps me up at night. I built a model. I don't understand what the model did or how it works, but it was accurate, and that's all that matters. And James, that keeps me up at night.
That keeps me up at night too.
Yeah. So I'm definitely going to come across as, a bit grumpy about those types of statements. I don't support the black box type of approach. I think we have to understand what we're doing as engineers. But I'll tell you, let me just finish on one thing. And that is, I promise you that as any good keynote talk, there will be an invitation.
Love it.
I will provide demonstrations and I will leave you with products and I will invite people, if they haven't, to get started.
Awesome.
Okay.
That is the hallmark of a good keynote. Wow. Well, Dr. Pyrcz, I can't wait for September and certainly really, really appreciate all that you are doing in your field and beyond, and all that you're doing to inspire that next young person who doesn't know that they want to be an engineer yet and is just on the cusp of discovering that. So thank you for motivating others and encouraging others to be the best people that they can be.
The whole world for me is a gas station, James.
I love it. I love that. That's a t-shirt right there. Well, Dr. Pyrcz, thank you so much for your time today. And we're very much looking forward to seeing you in September.
It's been a pleasure. Thank you very much.
Thanks for listening to this episode of Problem Solved, the IISE podcast, a production of the Institute of Industrial and Systems Engineers in Metro Atlanta. This podcast is produced by David Brandt, Keith Albertson, and Michael Hughes, and edited by David Brandt. You can listen to all episodes of Problem Solved and learn about sponsorship opportunities by visiting our website, podcast.iise.org. You can also learn more about IISE at the Institute's website, www.iise.org.